are molecular shapes. These shapes are only for covalent compounds, which are nonmetals and nonmetals. Molecular compounds have shapes based on the Vsepr theory. I know, y'all, it looks like it should say Vsepr, but it's Vsepr. The letters stand for valence shell electron pair repulsion. No, I didn't write that. The electron pairs repel each other, and the molecular shape adjusts so that the atoms are as far apart away from each other as possible. You can say that they bond or they share as far away as possible. Okay, so remember the lone pairs lie closer to the central atom and repel more than a bonded pair. Alright, so if we just have two atoms together with no central atom, of course that will be linear. An example will be HI or N2, whatever. Okay, if we have two atoms around a central atom with no lone pairs, will also be linear. These guys are 180 degrees bonds. Carbon dioxide was a great example. We have two bonded pair, but no lone pairs on the central atom. Now, bent, we can have bent that has two atoms around a central atom with lone pairs. We can have it with two lone pairs like water, or we can have it with one lone pair. So these guys with two bonding pair and one lone pair are going to be 119 degrees. Or if we have two bonded pair and two lone pairs, these guys are 104.5 degrees. Okay? Alright, so like I said, water is a great example. Those, we just got through drawing water for it to look like this. Yes? Well, these lone pairs kick it out of the plane. And so it bends the structure. Okay? Questions? Alright, trigonal pyramidal, two examples. BF3 is one example, or ammonia is the example here. I can't remember what the other example is I use here. But we have three atoms around a central atom with no lone pairs. So boron. So it's a trigonal pyramidal. A trigonal planar. And these guys have 120 degree bond angles. And it's the bond angles that really tell how these guys are put together. Then we have trigonal pyramidal. These have three atoms around a central atom with a lone pair. And they're 107 degrees apart. An example will be ammonia. So this lone pair kicks it out of from the plane into a pyramid. And they will end up being actually 107 degrees apart. So the correct way to draw that would be nitrogen with our lone pairs up here, hydrogen, and then this guy's back behind us. So that would be better. Yes? It's behind. This means that it's behind. I know, I wish I had structures, and we're going to end up doing a marshmallows and looking at marshmallows. You see how this one looks with this, Melvin? You see how this guy looks right here with it back behind it? So that's basically what this looks like, except instead of this being a bonded pair, it's a lone pair. That's what trigonal pyramidal looks like. Okay?
So like whenever there's like the electrons that aren't bonded to another element,
the lone pair?
Yeah.
The lone pair, that's what we said here, that the lone pair reduces the bond angle by approximately 2.5 degrees. And it's the lone pairs lie closer to the central atom and hence repel more than a bonded pair. The order of strength. So what I mean is this line is not as long as that line. Okay? Because these guys sit closer. Okay? So then for tetrahedral would be like methane or carbon tetrachloride, any of those. So 4 atoms around the central atom, and these are what, 109.5 degrees apart. So carbon, throw some hydrogens around it. There you go. And each one of these bond angles are 109.5 degrees. All right. So let's go back and look at your examples here that we did and see if you can identify the structures.